Hello, everyone. Thanks for joining us today. We'll wait one more minute to make sure that everyone's able to log in and get to the broadcast. Thanks for joining, everyone. I'm seeing people trickle in here, so great of you to spend your Tuesday with us. And I know we'll hear very shortly from Nick about all things geospatial, so wonderful. All right, I don't want to go too far past the 30-minute mark, so welcome, everyone. Thanks for joining us today. As many of you know, it's been about a year since Unfolded joined the Foursquare family, and today we'll catch you up on all things Unfolded and some of the innovations that have been made to help transform geospatial analytics. My name is Janice, and I lead marketing operations here at Foursquare, and I'll be moderating the discussion today. As you know, you'll hear from Nick Rabinowitz, who does a number of these wonderful webinars for us, and he's our senior staff engineer, and he'll talk about all things geospatial. Just a few housekeeping items. Please ask us any questions that you might have. We will have a Q&A at the end of this session, and we'll be hosting a fireside chat on the Unfolded Slack channel to follow as well. So if you've got questions and we don't get to them during the presentation today, we'll make sure that we answer them during our Slack conversation to follow. And on the last slide of today's presentation, we'll make sure that you have all of the details to join in that session. So without further ado, Nick, please take it away.
Thanks. Hi, I'm Nick Rabinowitz. Just a very brief bit about me. I'm a senior staff engineer at Foursquare. I've been at Foursquare for about a year, and before that I was at Unfolded when it was an independent startup for about a year. Prior to that, Uber, ClearStory, and a bunch of NGOs and nonprofits. So I've been a software engineer for many years, focusing mostly on mapping and data visualization. And I also work on the H3 project, which I'll talk a little bit more about in this presentation, but it's a hexagonal grid that I love to talk about. I'm also an avid geocacher, which I started, it's a hobby I started during the pandemic, and it means that I love to use maps and geospatial data to find things. I wanted to give you a brief overview of the agenda. I'm going to start assuming that you don't necessarily know the Unfolded Studio product and give you a very brief introduction to what that looks like. And then I'm going to talk about really what we've done over the last year to improve the product after we've joined Foursquare. What are all the things that we've really made happen now that we're part of the Foursquare family? You can get a teaser here. We have more data, more visualization, and more insights. So a brief intro to Unfolded Studio. Unfolded Studio is a geospatial data application, and it's meant to make it really easy and straightforward to bring in whatever data you might have that has some geospatial aspect, put it on a map, and see it in a variety of different ways. So in this case, we're looking at earthquakes over many, many years in California. And we can see this as a bunch of dots with color coding by the kinds of metrics that we're interested in. For example, here we're color coded by depth. We're sized, I think, by magnitude. We can use different layers to view that data in different ways. So here's something that's a bit more like a gridded heat map of the same data. So you can see where there are more earthquakes and where there are fewer earthquakes over time. We can use powerful layers like clustering, for example, to group things together and get yet another perspective on the data. So I think of this as an exploratory analysis tool, which really means that it's great for asking a lot of questions, finding the answers to those questions, coming up with new questions that you want to look for, and going through an iterative process with your data to find insights. We've got a lot of different support for a lot of different kinds of data. In this case, we're looking at polygons, so we can look at these are all, I believe, all of the buildings in San Francisco and their ages. You can get a really at-a-glance view of where there's been new development, where the buildings are older, and it makes you both get a quick understanding of the data, but then also be able to look and pose questions dig in and look for new perspectives. We can also support things like raster and 3D layers. So this gives you a way to look at your data in a way that might be better for presentation, or might just give you a view that is more realistic and gives you a better sense of what's going on. In this case, this is looking at wildfire burn in California as well. And you really get a visceral sense of, which sides of these mountains were burned in the wildfires. We also offer, in addition to just showing you the data, we can give you a lot of tools, for example, powerful filters to slice and dice your data, or other ways to perform different kinds of geospatial analysis or different kinds of geospatial operations on your data, to allow you to work with it, either one data set or to join it with other data sets, unify multiple data sources, and get different kinds of insights out of them. So that's roughly what we started with in June of 2021. That was about a year ago when Unfolded joined Foursquare. And the way I think of this merger, I was not involved in the merger. I'm not an M&A guy, but the way I think of this merger is that we were an analytics company with no data, and Foursquare is in many ways a data company, but didn't have an analytics product. And so put us together, and we can really do some amazing things. So what I want to talk about is all the things that we've built since then, all the things that we've done in the last year that really improve Unfolded's ability to do geospatial analysis in the product. So to start with, we are providing access to more data, and there's a lot of different ways you can look at that. We provide access to much larger data sets than we used to before through our new Hextiles system. We have built out a growing suite of data connectors that allow you to access your own databases, either from the cloud or in other ways. You can access your own data stores and get that right in the product without storing it in our storage. You can even look at custom raster layers that you've built on your own end, or that you have access to from public sources, and import your own cloud optimized geotiffs. So just a brief aside, I said I wasn't going to talk much about H3, but I can't help talking about H3 sometimes because it's very important to the Unfolded product. We have a lot of features built on top of it. So I won't go into depth, but H3 is a hexagon-based grid system that we use for a lot of analysis at Unfolded. It's a way of splitting up the world into equal area bins. Here you can see just the top levels, but it goes all the way down in a hierarchical grid system. It goes all the way down to under a square meter. So it gives you a very precise way of dealing with geospatial data using these equal area shapes, and we can build a lot of things on top of it. And the most exciting thing that we've built recently is the system called Hextiles. So you might be familiar with geospatial tiling systems like raster tiles or vector tiles. Hextiles are a new tiling system, something that we started to build at Unfolded and completed while we were at Foursquare, and it fits in very well with the Foursquare ethos, because Foursquare is all about dealing with really large, really detailed data sets, things that have millions or billions of data points, not just the amount that you might easily be able to load into your browser. Hextiles is a way of dealing with those data sets so that you're only looking at the data that you need, you're only working with the data that you need at any given time. And we can split up the world into these hexagon-based shapes, and we can easily bring them into the app for analysis. So this is a multi-resolution system. As you start at the top level, you have a sort of coarse overview, and then as you zoom in, you get finer and finer. I thought I would give you the live view of this. So here's this population data set, census data set, and as we zoom in, we load finer and finer tiles, and we can get more and more detail in our area of interest. So you can see that the whole data set, has potentially billions of data points here. We're down to a very fine-grained level, but we can show you both the fine level, the details, and we can show you the overview. You can choose what part of the country you're looking at, what things you're actually interested in, and load only that data. It allows you to work with these very, very large data sets in a way that's really smooth and simple to use. On top of this Hextile system, we've built a series of public data sets that are available in our catalog. Many of these come from data sources like the census, but we have other things as well. We have elevation, we have road and building data sets, we have land use data sets. There's a lot of sort of general purpose data sets that we make free for use in our catalog. And these are really easy to bring into your own analysis and join with your data and do additional operations. So for example, it's very simple to choose an area of interest and extract this data set for further use. There are some things that are going to be easier to do with a small portion of the data set. For example, if you wanted to download it and do anything external to the app, or if you wanted to just do certain types of operations or joins, it might be easier to work with only the subset of the data you're interested in. You can easily select a polygon or a rectangle and pick the data you want and get it right out as its own data set. You can also use this data for enrichment. So we have this, massive census data set. If I wanted to go back to my earthquake example, join it with my earthquakes, I might want to be looking for the place where there are earthquakes in highly populated places, for example. I can join the earthquake data set through an operation we call enrichment, and easily add that population number to every data point in my earthquake data set. As of about a month ago, we now allow you, the end user, to create your own Hextile data set. So this is a great way to work with data that is too large to otherwise use in our system. So up until this point, one of the great things about Unfolded from a technical perspective, and I'm an engineer, so I'm always thinking from the technical perspective, but one of the great things is that everything happens in the browser. And the reason this is great is because it's very, very fast. It doesn't have to go back to some server, do some long operation, come back to you. We can do these really smooth operations in things like filtering or panning and zooming, and not have to load in new data. Hextiles allow you to have that same ease of use, that same flow with data sets that might be up to several gigabytes, which is not something we could previously load in the browser. So we have a fairly simple interface for creating your own Hextiles, and then you can bring them into your own analysis. One of the new things we've added as well is the ability to join tile sets. And again, as an engineer, I'm super excited about this, because usually if you wanted to join 5 data sets that were many gigabytes each, this would be extremely difficult, time consuming. It would be the kind of thing that you might spin up a Spark job for and come back an hour later. And in this case, because we're only dealing with a tile by tile join, so the join key is already very obvious. You're just joining on the hexagon in each tile, and we're only joining the pieces of the data that you need. So you can actually browse around a joined data set in your browser and zoom into areas of interest. Those are automatically joined for you. You see them right away, and you can put these together and create new metrics and new insights from them. So for this case, for example, I've joined this age data set with an education data set and an income data set. I've put them all together, and I've come up with this maybe specious at-risk child score, which is, where are places where there's low education, there's low income proportion, and there are a lot of children. I don't know if that's a valid analysis, but it's the kind of thing you can do to pull out insights from multiple data sets at once. And this process of putting these different data sets together was very smooth and easy. I also wanted to talk about our data connectors. So many folks who come to Unfolded come, bringing their own data stores. Not all of your data is in a flat file. Not all of your data is available as a CSV. And in many cases, you might have a large data store that you already work with and want to see immediately in the app. And so we've been building out a suite of data connectors. This will grow over time. You can see right now we have Snowflake, BigQuery, Athena. We have a Planet data connector for Planet's raster data. We have a Postgres connector, and we're building out PrestoDB and Earth Engine right now, and there are more in the works. And so these are all different things that you can use to connect your data store directly to our app. One of the great things about this is that we don't then store any of your data. So if you are concerned about the privacy of your data, if you're concerned about the security of your data, something you don't want to put in someone else's cloud storage, it's very easy to bring it right into the app, never gets stored in any kind of way in our system. Again, there's a pretty easy setup screen for this. You're basically just putting in some credentials, which we encrypt and store securely. And then we can give you an interface that basically gives you the same SQL-like interface you might have to interface directly with your data store normally. So you can write SQL, you can write whatever language your data store will accept, and we can get back those results right in the browser and show them immediately on a map. Finally, I just wanted to quickly point to the custom raster layers. This is something we've been working on for a long time, and I think we'll be doing more on it. There's a relatively new format called a cloud optimized GeoTIFF, which in a way is another way of taking a very large raster data set and putting it online in a way that consumers can take only the pieces they need and show those on a map. And to go along with that, there is this idea of stack metadata, which is a standardized metadata format for describing geospatial content. And so we can put those things together, allow you to just give us the URL to your stack metadata, to the stack metadata for some COG data set that you're interested in, and immediately import that into our map in a way where you can see it overlaid both on the base layer, but along with your other data, and unify it with other kinds of data that you're using for analysis. Moving on, we've also done a lot more visualization. So we're not a visualization tool in that we're not built specifically to generate an external visualization, but we do make beautiful visualizations, and visualization is a huge part of our tool in terms of providing the overall view of your data to your eyes, I suppose. We are by nature, humans are visual processors. We have amazing visual processing units in our brains. And so visualization is a really great way to understand far more data than you would be able to comprehend in most other ways. You can see only so much data if you're looking at a table, or if you're looking at one or two big numbers. With visualization, you can see literally millions of data points and make sense of them. And so we've added a variety of new visualization features to the app over the last year, starting with charts. So this was a highly requested thing that, it's great that I can see this all on the map, but I also want to know, what's the total? What are the top categories, for example? This is a map of accidents in New York City. We can quickly look at the charts on the right, and we can see, the total number of accidents in the data set. We can see, in this case, which streets have the most accidents. So 2nd Avenue apparently is a dangerous place to be in New York. I don't spend a lot of time in New York, and I definitely don't drive when I'm in New York. But if I did, I would now know to avoid 2nd Avenue. And this also works really well with our filters. We can filter either geospatially with a polygon, or we can filter with other filter controls on categories or metrics. And the charts will update automatically. So it's a really easy way to get a summary of certain subsets of your data as well, and to move that polygon or slider around and see how things change, and how the overall stats change when you change the filters. We can also take these charts and we can put them right in the tooltip. And so when you're looking at the charts in this previous screen, you're seeing the overall view of your data. Here you get down into the details. So this is a map of visits in a particular city, and we can look at a graph for every single, in this case, hexagon in the map. We can look at a graph for when people visit this particular hexagon, what times of day are most popular, which of the demographic segments are most popular. I should give a side shout out that this is one of the ways that we've started to integrate Foursquare's amazing visits data set into our maps. So you can really get detailed information about foot traffic to different locations all around a city that you're interested in. As another example of this, you can also get time series information for every single point on a map. So it's great that we have this visits information. We can show it at this macro view. You can see where there are more or fewer visits, but you can also get this really fine-grained view of, for this particular point in this particular city, what was the time series of the visits and how did they increase or decrease over time. Finally, we're using graphs as well for this overall summary view. So we've been trying to get better and better at giving you ways to quickly understand and work with your data. In this case, we're using histograms as a quick way to give you an understanding of how the data is arranged, what's the shape of the data within a large data set. We've also started to add some really interesting new layers. This one is called a flow layer, and it gives you a picture of origin and destination flows between different points in a given city. I think this is city bike data, and we're looking at different points within New York, and you can see you get these big fat arrows where there's lots of traffic between 2 points, or you get lighter and lighter arrows when there's less and less traffic. So this is a way of taking this really complicated matrix problem. This is essentially a matrix or a graph of different nodes. Every node has a weight, and giving you a visual representation that you can quickly use to derive insights. So I can see very quickly, like where around the East Village we're getting a lot of city bike traffic, and around the Meatpacking District or Chelsea we're getting a lot of city bike traffic, but less so on the, this is my poor New York knowledge, but I believe that's the Upper East Side, and there's less bike traffic there. And similarly, we can use the charts that we put into the tooltips that I showed you in the last couple slides. We can use that to derive more specific information about these different nodes in your flow chart. So you can look and you can see, for this particular location, East 10th Street and Avenue A, what are all the origins that are coming here? So where are people coming from when they want to get to this point? So again, this is a way of understanding a fairly difficult data set, a mobility data set, and getting a quick understanding of, how are people moving around the city. Another sort of new layer that we've added is this improved trip layer. So our trip layer previously was about drawing lines on a map. Now we've improved it in a way where you can you can draw lines through the air. So we now support altitude. We also support these 3D models to show you how things are moving. Obviously, this is a pretty particular use case of seeing flights, but you can imagine similar things for cars or other kinds of fleets of vehicles that you want to see. And the animation on this is so cool that I wanted to show it live as well. So you get these 3D models that you can animate in real time, and we can support not only a few of them, but hundreds at a time over a large area. You can zoom in and you can actually see how they're working over the landscape, and play back and scrub, so you get a particular view of how things are working. It's a really powerful way of seeing, again, a very complex data set, which is hard to understand at a glance. You can really play through it, zoom into your areas of interest, understand how things are moving at the time you're interested in. So this is that visualization again. It's just sort of giving you the impression of how much data we can handle at once, and you can adjust the visualization in many ways. Pretty much all the visual elements here are adjustable to handle more or fewer items and more or fewer vehicles, and to get a real good sense of how things are moving over time. So the new layers are great, and the new charts are great. But as a visualization professional, I tend to think that it doesn't matter unless you also get the details right. And we have worked really hard to get the details right. And so one example of this, there are many, obviously details, there are many, many examples. One example I wanted to bring out was this, was Jenks natural breaks, because it's something I've wanted to see in our app for a while, something we now have, and it really actually makes a big difference. So when you are assigning a color scale to a series of values, there are a lot of different ways to do it. You can do it quantized, where you basically just have an evenly divided color scale. You can do it quantile, where you're dividing it up depending on how much data you have in each bucket. Jenks natural breaks is a long-standing algorithm for identifying something that will be visually meaningful, breaking up your data into visually meaningful sections that you can color differently. And to give you a sense of that, over on the left here, we have this water data set with a quantile scale, and you can kind of see where the water is, but you don't get a lot of differentiation. You basically only come up with 2 of the colors in your color scale. Over on the right, we have the same thing with Jenks natural breaks, and you get a much finer grained view of where there's a lot of water, where there's a little bit of water. You can really see the Sacramento River delta and all the things that feed into it. You can see how this feeds into the bay, just in a much clearer sense, just by assigning the right colors. Color theory and color scales are a long-standing sort of theoretical problem for visualization folks, and there's a lot of work that has been done there that hasn't necessarily gone into applications. I'm excited that we put it into our application. We also give you the ability to change colors, to adjust things. For example, here you can see how we've allowed you to change colors in the base map. And this allows you to fine tune things when you're making a careful visualization that either has where color has a particular meaning, or where you just are fine tuning something from a design standpoint to present to others. One other thing I want to note here is the ability that we've added to sync the timeline for different data sets. So it used to be that you could add these time filters, and they allow scrubbing and a lot of powerful filtering, but they don't necessarily allow you to work with multiple time-based data sets together. Now we've added this syncing capability. Again, I'll do the world's shortest demo. So you can just sync these 2 things over time. You can see that both the dots and the density areas are changing, and you can zoom into your temporal area of interest and have that filtered for both data sets at once. So that makes working with multiple time-based data sets just a much simpler task than it previously was. And finally, we've provided a lot of ways to get more insights. So obviously, data and visualization are great, but you don't come to an app for data and visualization. You come because you want to answer questions. You want to understand things. And we've added more and more operations and modules that allow you to pull out those insights faster and do more work with data in our app. The first part I'd like to pull out here is this set of spatial operations that we have added. So this is something that has long been a standard of the sort of super expensive professional grade GIS tools, but hasn't really been heavily available in most consumer products, I would say. And this is something where we're really aiming not just at the GIS professional, but at a wide variety of people who might want to deal with geospatial data. And now those people have the ability to do some of the kinds of things that GIS professionals used to have as their private purview. So for example, here I have all the blue dots are trees in the city of Oakland, and the light blue polygons are different neighborhoods of Oakland. I can join either the trees to the polygons, in which case I would have a neighborhood associated with every tree, or I can join the polygons to the trees, in which case I can get a count of every tree, for example, or an average of every tree height within each neighborhood. So in this case, I've just taken a simple count. I have this spatial join, and now you can see the neighborhoods in Oakland that have more trees, the neighborhoods that have fewer trees, and it gives you a different view of how things break down over a neighborhood than you might get just from looking at the dots and the outlines. So that's one way that we've made it really easy to unify diverse data sets. In this case, not only different data sets, but different data formats. You've got points, you've got polygons. We bring them together and allow you to ask questions of the unified data as well as the individual data sets. One more thing we can do, and I'll just show quickly, is to merge areas. So if, for example, I wanted to classify these different neighborhoods and merge into just a couple of polygons, now I can do that. I can merge these things together. I have one big polygon that represents neighborhoods with lots of trees, one big polygon representing neighborhoods with fewer trees, and I can use that for further kinds of analysis. One last thing on the spatial operations that I wanted to point out, again, something that I've wanted to see in the app for a long time, something that's common in professional GIS tools, but uncommon in other kinds of data analysis tools, is a buffering operation. So here again are the trees on each street, but but you might not be able to, for example, join these with the streets themselves, because the streets themselves you might have as a line data set. The trees don't actually overlap those lines, they're just points. So what you really need is some area around the tree that will allow you to join it with other kinds of data sets. And in this case, we can apply a simple buffer. You can figure out how many meters, or in some cases, how many miles you want to buffer your data. And now we have a polygon associated with each tree that's a little circle around it. And we can use that for different kinds of analyses than the points would allow us to do. For example, you could now find other points that were within 20 meters of a tree, instead of just finding something that was exactly where the tree is. Finally, and I think this is maybe the most exciting thing to me, is we've got a bunch of work putting together analysis modules that give you a more in-depth and directed approach to doing more complex analyses. So, all of our sort of building blocks within the app allow you to do many, many things, but it can be hard to do something that's a more specific type of analysis. And there are many types of well-established, useful analyses you can do based on geospatial data that have been around for a long time, but again, not always accessible in applications like this. So for example, in this case, we have this cluster and outlier analysis module that allows you to look at some data and cluster it in useful ways. In this case, I'm looking at unemployment rate by county throughout the United States. If I apply the cluster analysis module with some levers and some dials, I can quickly get this clustered output where I can see large clusters of low unemployment, large clusters of high unemployment, and places where it's not statistically significant one way or the other. They don't necessarily fit into a cluster. There's also the ability here, though it's a little hard to see on this particular screenshot, to find outliers, areas of high unemployment that are surrounded by low unemployment areas, for example. So these are spatial outliers that might be really interesting things to look at for certain types of analysis. Our goal is to add more and more of these sort of high-powered analytical modules to make it easy to do these kind of professional grade analyses that would otherwise really take a GIS professional and sometimes software that costs many, many thousands of dollars just for one user, one seat. Quick taste of things that are coming soon. We are working on better management of maps and data sets. We're working on more improvements to our map and data SDKs. These are ways that you can build your own applications or even just Python notebooks that interface with our application. More data connectors, as I mentioned. Better support for many of the core data sets that Foursquare brings to the table. New analytical modules, as I mentioned, and much, much more. We have a lot of things in the works. So thank you very much for taking the time to go through that with me. I really appreciate it.
Thank you so much, Nick. And I know that we're cutting it short on time, but just very quickly, we want to make sure that you're able to kind of hear some of the questions that have been asked, and you're welcome to join us on Slack at the Unfolded Slack channel, and you'll see the Unfolded Slack details are included here. Obviously, at any point, you're welcome to work within the Unfolded Studio, studio.unfolded.ai, of course, for those of you that have been there before, that you're no stranger to this. And then finally, we will be hosting a webinar on August 9th. We did receive some questions, but I know that we're short on time, so I will conclude with one of the questions that we got, and the rest we can answer in our Unfolded Fireside, which is of course available asynchronously. So even if you're not attending in real time, you can visit the Fireside and attend later. But the question that I can call out here is, how are hex tiles different from other tiling systems like raster or vector tiles? So Nick, if you don't mind answering that question for us, that would be awesome.
Sure, that's a great question. And in other presentations, I've had a specific slide on this, but I didn't put one here. The main way that I would differentiate them is I think of hex tiles as being data tiles. Raster tiles and vector tiles are in many cases meant to present a map, on a website or in a browser, but they aren't necessarily giving you access to the data within that tile in a way that makes it easy to work with if you're trying to do a data analysis or trying to join it with your other data. Hex tiles have been custom built for this purpose. So every tile in the hex tile data set is effectively a small data set that you can easily join with your own data. This is true somewhat for raster. You could make the case that, you know, every pixel in a raster image is like a row of data that you can join. But raster, among other things, doesn't have this sort of common unit of analysis. You have to geolocate the raster image. You have to figure out exactly how these pixels line up with the real world. And, you know, one raster data set isn't going to be easily joinable with another raster data set. In the hex tile case, the H3 system gives you the geolocation and the common unit of analysis out of the box. So it's very easy to take this data, join it with any other data that has geolocation. And as I mentioned in the presentation, it's very easy to actually join these tiles together. You can basically just think of this as a tile sandwich where you're sticking them all on top of each other. They all have the same units, they all have the same size, and you know, you end up doing the world's easiest and fastest join on a tile by tile basis, which also as an engineer, I'm like, tile by tile, that means we can do it in parallel, which is great because it's much faster than doing other kinds of joins. So it gives you this really easy way to work with the data that's in the tiles, in addition to just being able to navigate through it and explore that data at scale.
Awesome, thank you. Well, I know that we're short on time. Again, we do have more questions that will write into the fireside. For those of you that can access the link here, it's the unfoldedpage.link/Slack sign up, and you'll see the Unfolded Fireside channel within. Thank you so much for your time, Nick, and thank you to everyone that's joined us today. We appreciate your staying with us on a Tuesday. Thanks. Bye-bye.
Thank you.